Hello, everybody. So I'm Aftab Siddiqui. I introduced myself in the morning. Let me reintroduce myself. Aftab Siddiqui. I work for the Internet Society, part of the Deploy 360 program. My friend Jan Zors was quite vocal on IPv6, so I won't bore you with IPv6 more stuff. I'll give you something different. So I would like to share my experience with the VXLAN. We did some deployments before joining the ISOC. I was involved in one of the largest deployment in Australia on VXLAN specifically. So I would like to share some experiences on that. I hope you'll like it. So, yeah, that makes sense. Anyway, so what is VXLAN? Can I have some show of hands if people know about VXLAN? Well, yeah, we have few hands. Good to know that. So the fundamental reason why VXLAN came into being, it's not very old protocol. It's a very new thing. It's a very new thing. It was the RFC came in 2014, and the discussion started like probably 2 years back or 3 years back. So it's not very old thing. It's one of the overlay model to address the number of VLANs, the limited number of VLANs we had. So it was only 4096 and plus minuses of some reserve runs. So we had a very limited VLAN, so you had to come up with an idea to address that. And that's why we have so many overlay models. VXLAN is one of them. Then we have NVGRE, OTV, Lisp. There are more coming in, but VXLAN got the most traction and the most deployment in the industry. So VXLAN is Virtual Extensible LAN, defined under the RFC 7348, authored by a mix of vendors, Cumulus Networks, Arista, Broadcom, Cisco, Red Hat, VMware, Intel. So it was done by a lot of vendor, and they came to a conclusion which is very strange at times. Anyway, overlays is just layer 2 over layer 3 to get you extension of a layer 2. It's simple. It's just it shows in the diagram. Enables layer 2 interconnection across layer 3 boundaries. So it gives you, rather than extending the layer 2 boundaries it gives you an extension that you use layer 3 in the middle and then you extend it. I'll explain it through diagrams. It will make simple. Terminology, the two key terminologies. So in VLANs, what we had VLAN identifier. In VXLAN, we have what it should be. The simple VXLAN identifier. The name is VNI, Virtual Network Identifier. So it's a 24-bit number. So it doubles the number of VLANs. We had 4,000, now we have 16 million. So it's likely not to run out in a network. The VTAP, which is the virtual endpoint, which is the last segment where the VLANs, the VXLAN is terminated, and then use the layer 3 model. If you take a look at the diagram, so this is the customer edge sending all the VLANs, and then VTAPs is connected to the layer 3 segment and sending it to the other side of the network over the layer 3 networks. And then the de-encapsulation happens on the other side and you have the VLAN again. So why VXLAN? As I said, it is just one of the overlay model. There are plenty of others available. So it was very simple to just use a mix of all of them. The best thing about the VXLAN is it has a wider range of industry acceptance because, as you saw in the RFC, a lot of vendors got together and did the RFC work, so it has a wider acceptance. the most common chipset available in the market these days. White label switches you can use easily with that. Well, you can use it with Cisco, Juniper, Arista as well. It supports point-to-point and multi-point, UDP header, and wide vendor support, as I said. This is the packet. It's a bit complicated. It adds a complexity to what you were thinking in a VLAN. VLAN was pretty simple. Well, you have added a complexity to it. As it said, there are 50 bytes added, and this is how it is. So this is the VXLAN header. Then you have you have the UDP, and then the outer IP packet and the MAC address outer. So if you add all of them, it's a 50 byte packet. This is the packet capture of one of the VXLAN header. It gives you the same picture. So destination port, which is 4789. So every packet is destined towards the fixed port, that is 4789. So let's talk about the use cases. I'll just keep it simple and we'll just talk about the use cases. So why you want to use VXLAN? Let's take an example here. You have a layer 2 segment where you're using Q&Q, which is quite common in the Metro Ethernet these days. And then you're just sending all the VLANs you're receiving from a customer end to the other side. Well, that makes sense. If you have a stretched layer 2 segment, that makes sense. But you have layer 3 segment in the middle. So what you have to do is you have to come up with a tunneling protocol. So that's how you can provide that. So you don't care how many VLANs coming in from the customer's own segment. You just take care of the outer segment and then assign it to the VNI. So every outer VLAN has been assigned with the VNI, and then you send it to the other end. And while the decapsulation happens here, it removes the VNI, put back the outer VLAN, and then send everything as it is. So these two VTAPs, the tunnel endpoints, they don't care what's coming inside. They only care about the outer segment, the outer VLAN. So this is the packet capture. So as I said, they don't care about the inner VLAN. So there was 500 inside. When the packet was encapsulated in a VXLAN, this 600 was replaced by a VNI, which was and 600 was replaced with the VNI, and the inner VLAN 500 remained as it is. There is no difference in that. So if you have 500, 400, 300, if you have multiple VLANs inside a Q&Q packet, it remains as it is, untouched. And you can send as many VLANs as you like over a layer 3 segment. So why it is important? The use case. If you have multiple data centers, and if you want to connect multiple data centers, what are the options? Either you buy a dark fiber between the data center, or just capacity between the data center. If you're buying a layer 3 capacity between the data centers, you can use VXLAN to connect your data centers. It doesn't cost you a lot in terms of either buying a dark core or a dark fiber, right? You just use the layer 3 segment capacity between the two, normal IP or MPLS capacity between the two segments, and then you can use the VXLAN. And you can send as many VLANs you want from one data center to another. But the sole purpose of the VXLAN was for the cloud providers, they had the limitation. If you are a small enterprise or even an ISP, 4,000 VLAN is still a lot for you. But for a cloud provider who are selling VMs in thousands and hundreds and thousands, 4,000 is a very small number for them. So they needed a bigger number for that. And that's why the VXLAN came into being. And if you have multiple racks of server and if you want to provide VMs without any boundaries, you need a VXLAN. If you want, you have multiple racks of server, and if you create a layer 2 domain with VXLAN, one VM can reside on one rack, the other VM can reside on the other rack, and between these two racks you can create a VXLAN. And for a customer, it's transparent. For a customer, it's still a layer 2 boundary. They can talk to each other in the same broadcast domain, but technically it's on a different machine on a different rack, and in between that you have a layer 3 segment through which you can manage the equal cost multipath, and you can manage the more capacity without having to deal with the STP or anything else. So, well, as it's not a solution for everything, right? So if you're saying that, oh, fine, I can use VXLAN for everything, it's not. There are certain limitations because it was designed for very specific use case, and it works fine with routing protocols. It works fine with VLAN, QNQ, as I said. Multicast, of course. It doesn't work with LLDP. It will break LLDP. If you want to create LACP, then it doesn't work. If you want to do COS preservations, it will kill all the COS marking if you send it across the VXLAN segment. You cannot preserve it because it removes the outer VLAN, and all the COS marking is on the VLAN. So once you're removing it, it's gone. So there are certain issues, and of course it kills the 802.1x as well. So these are the issues which you have to understand before implementing VXLAN. What we did implement, as I explained before, what we did implement in Australia, it was like that. It was a DCI data center interconnect for a large data center provider in Australia, and they had multiple data center all across Australia, so we did the DCI. Summary, operationally simple, Ethernet light services, eliminate protocol dependency and complexity, expand vendor choice. The interoperability is very well tested and deployed. You don't have to rely on a single vendor for a single solution. Practical and economical deployment. In terms of complexity, as I said, it adds a little bit of complexity because of the larger header side. You have to have jumbo frames available, otherwise it doesn't work because it adds 50 bytes of header. Future use case, remote tap transport. If you have to do the tap, or if you need tap for any purpose at a remote end, you don't have to do anything. You just create a VXLAN with a span port and bring it back over layer 2 channel. So it works fine. We have tested in the lab if you want to get more information on that. Hub and spoke E-line services, more mobile management application to deliver self-services. These are the use cases which can be fruitful in the future, but I'm not sure if anybody else used it today. But that's how it is. If you have any questions, please just let me know. It was just a small presentation. Sure, go ahead.
Hello, my name is Ali Hani from Lebanon, Siddiqui. When I see this protocol, how it's working, I see a lot of similarity with MPLS. So instead of getting labels in and out for the switching protocol, we can see virtual network identifier and So this protocol is it compatible with MPLS network, or is it to replace the MPLS, or the future of MPLS, or how exactly does it will be used? Because whenever you say let's to connect multiple data centers virtually, let's say to open the tunnel, we can do this with virtual circuit on MPLS, so it's almost the similar one. So where does this stand from the MPLS protocol?
So you're absolutely right. You can achieve the same functionality through MPLS, VPLS to be exact. If you are looking for a point to multipoint, you can. Simple as that. There's nothing wrong with that. In fact, if you do VPLS, you can still manage LACP and LLDP. It works with that. So why VXLAN? The thing is, you can push VXLAN to the host, right? You cannot push MPLS or VPLS to the host. You can use VXLAN on a virtual machine, on a VM itself. You can't do that with VPLS. So in terms of implementing MPLS or VPLS, you have to have a bigger box to do that. So on the diagram 4, in this case, you can push it up till the host, and from there you can create the tunnels. That you cannot do it with VPLS or MPLS. So that's the additional benefit. Or because we are moving towards the container and routing to the host, it makes a lot of sense to have a VXLAN rather than implementing VPLS. It is because most of the implementations of the VXLAN available at the moment are purely on Linux. So you can just install a module and here you go. So it's simple, it's easy to maintain, but it gives you the exact same functionality which VPLS is providing. VPLS gives you more functionality, as I said. It gives you LACP, LLDP as well, and 802.1x. If you are looking for that, go with VPLS. But if you want to have something like this, the use cases I've explained, two which I am aware of, there could be many, but then yes, you can do it. And as a service provider head or a network engineer head, I would love to do things which are open, simple, and easy to deploy. Otherwise, yes, you can do the same thing in a very different manner through different protocols. Yep. Anybody else?
Any other questions? All right, thank you, Aftab.